Late one night, astronomers spotted something that made their hearts skip a beat. 3I/ATLAS, the mysterious interstellar visitor hurtling through our solar system, seemed to have split in two. A faint second object appeared, gliding almost perfectly alongside its massive companion, like a shadow keeping pace across the void. Questions raced through the minds of scientists worldwide. Was this simply a fragment that had broken off, or something far stranger? The news spread like wildfire across space agencies. NASA, the Minor Planet Center, and the European Space Agency scrambled to track the unusual movement. NASA scientists panic as 3I/ATLAS's path ends in the worst possible location near Mars, a spot that could put orbiters and rovers worth billions at risk. No one could explain why this breakup happened so far from the Sun, where comets are normally stable and calm. Some scientists suggested slow gas escaping from within Atlas could be the culprit. Others whispered about forces we don't yet understand, recalling how Oumuamua's strange motion baffled astronomers back in 2017. But here's the shocking part. Neither Oumuamua nor Borisov ever broke apart. If Atlas truly split, this could be the most bizarre interstellar mystery humanity has ever witnessed. And right now, as telescopes around the world follow its shadowy twin, the story is still unfolding. Every second counts, and no one knows what will happen next. Before we dive deeper into the evidence, make sure to subscribe, hit that like button, and drop a comment. Do you think this is just a natural breakup, or could Atlas be hiding secrets no one is ready for? It began as an ordinary night, the kind astronomers know well, screens glowing, dashboards humming, telescopes quietly sweeping the heavens. But then, just past midnight, the calm shattered. The Minor Planet Center's monitoring system lit up with a string of alerts. A strange anomaly had been flagged. At first, it looked like nothing more than a faint smudge against the black canvas of space, barely distinguishable from static noise. Yet the coordinates matched something extraordinary. The interstellar object 3I/ATLAS. The Zwicky Transient Facility at Palomar Observatory had been running its routine sky survey when its automated system froze on the oddity. There it was, a second faint blur, offset by only a few arc seconds from Atlas's known trajectory. Analysts blinked, refreshed their screens, and ran the numbers again. Surely it had to be a glitch, a sensor malfunction, a ghost image caused by starlight. But the smudge didn't go away. With each fresh scan, the anomaly persisted, steady and undeniable. Inside the control room, whispers turned to frantic typing. Check the timestamp, compare the logs, run it again. Emails and Slack messages began firing across continents in the dead of night. Within minutes, the MPC's night shift escalated the anomaly to higher channels. Possible fragment. Confirm ASAP. The tension thickened as astronomers leaned closer to their monitors, their hearts beating faster with each recalculation. Then, confirmation arrived. Independent observatories thousands of miles apart, the Very Large Telescope in Chile, NASA's Scout System in California, all reported the same thing. The faint smear wasn't an illusion. It was real. A second object was moving alongside Atlas, trailing just behind it like a phantom twin. The chatter exploded. This wasn't supposed to happen. No interstellar object had ever shown signs of splitting before. Oumuamua passed by as a single shard of mystery. Borisov blazed like a normal comet, intact from start to finish. But now, Atlas was breaking the rules. A piece of something not born in our solar system, a traveler from the stars, seemed to be splitting apart right next to Mars. In those early hours, urgency replaced disbelief. Observatory directors across the globe debated in hushed but heated tones. Should they divert their most precious telescopes? Cancel scheduled targets? The risk of chasing a false alarm was high, but the cost of missing history was higher. Within 72 hours, The answer was clear. The global network of telescopes, ground-based giants, orbiting sentinels, even Mars orbiters, all turned their gaze toward the patch of sky where Atlas drifted. Humanity had just seconds, maybe minutes, of cosmic clarity before the fragment faded into the darkness forever. For the scientists at the front lines, the MPC analysts, the ZTF operators, the engineers at NASA and ESA, this was more than data on a screen. This was a once-in-a-generation event, a chance to capture the first interstellar breakup ever witnessed near a planet. The tension was electric. Each new image brought a mix of dread and awe, because the smudge that first appeared like nothing was slowly resolving into something undeniable. A real body moving in lockstep with Atlas. And as the evidence solidified, so did the fear. If Atlas was splitting, what forces were at work? Was this natural or something more mysterious? Could fragments racing at 60 kilometers per second endanger Mars missions? The questions multiplied faster than the answers, and the world of astronomy held its breath. But the night of discovery was only the beginning. What came next would challenge everything we thought we knew about comets, interstellar objects, and the dangers they might bring. Because once the split was confirmed, the next question hit like a thunderclap. Why did it happen at all? And that brings us to the next chapter, the deeper mystery of what could have caused the breakup of 3I/ATLAS. When word spread that 3I/ATLAS might have split, astronomers weren't just surprised, they were stunned. Why? Because what they were seeing wasn't just uncommon, it was nearly impossible. Sure, comets have broken apart before. History records a handful of such events, the most famous being Shoemaker-Levy 9 in 1994. That comet was torn into a train of glowing fragments as it spiraled into Jupiter's massive gravity well, before slamming into the giant planet in a series of cosmic explosions. It was breathtaking, unforgettable, and violent, but it happened inside our solar system. It made sense. Jupiter's tidal forces were strong enough to rip the comet apart like a fragile glass bead. But Atlas? Atlas was different. Atlas wasn't born here. It came from beyond the borders of our sun's dominion, hurtling in on a hyperbolic orbit. At nearly 60 kilometers per second, it was moving so fast that Earth, Mars, and even the sun's gravity could never claim it. This was a once-only visitor, a cosmic stranger racing through the neighborhood before vanishing forever into interstellar space. And now, here, in our own celestial backyard, it looked as though it had fractured. That's what made this discovery so chilling. Normally, comets only split when exposed to intense solar heating, when they graze too close to a planet, or when internal gas pressure bursts free. But Atlas wasn't anywhere near the sun. It wasn't locked in a deadly dance with Jupiter. It wasn't being shredded by tidal stress. It was, by all accounts, in a quiet region of space, drifting past Mars with no obvious cause for alarm. And yet, astronomers were seeing the unmistakable signs of a breakup. Imagine it, a shard of alien rock forged in some distant star system millions of years ago, crossing light years of emptiness untouched, only to fracture in front of us without warning in a place where nothing should have forced its hand. No precedent existed for such a thing, not with Oumuamua in 2017, not with Borisov in 2019. Both interstellar visitors had remained intact. Atlas was rewriting the rules of the cosmos in real time, and humanity had front-row seats. For the scientific community, the event carried a strange dual weight, awe and dread. Awe, because they were witnessing something that had never been seen before. Dread, because it raised an unsettling question. If we can't explain why Atlas split, then what other surprises might interstellar travelers bring when they wander through our solar system? Could such a fragment, moving faster than a bullet, become a hidden hazard to spacecraft, or even planets? The rarity of the moment electrified observatories around the globe. This wasn't just another data point, another cometary event. This was history unfolding, live in the skies over Mars. The eyes of Earth were locked on Atlas and its ghostly twin, waiting for answers. But the deeper astronomers looked, the less sense it seemed to make. The cosmos was keeping its secrets close, and that mystery leads us directly into the next burning question. What could possibly have caused three I/ATLAS to break apart in the first place? Why did three I/ATLAS split? That is the question burning in every control room, every observatory, every late-night data session. Theories swirl like dust in the void, but none of them fit neatly. And that's what makes this moment terrifyingly fascinating. Normally, when comets break apart, the culprit is obvious. Solar heating boils trapped ices, releasing gas with explosive force until the body cracks like a frozen grenade. Sometimes a comet passes too close to a planet and tidal stresses tear it apart, as Jupiter once shredded Shoemaker Levy 9. In other cases, hidden pockets of volatile materials rupture suddenly, blasting fragments into space. The rules are clear, and the patterns predictable. But Atlas laughs in the face of those rules. It isn't anywhere near the sun, too far away for solar heat to burn it from within. It isn't passing close enough to Mars or any other planet for tidal forces to matter, and no violent outbursts of gas have been detected. Instead, all the evidence suggests something subtle, something strange. Some scientists whisper about slow outgassing, faint jets of vapor that could, over weeks or months, nudge Atlas into a gradual fracture. But if that's true, then why now? Why in such a quiet region of space? Others suggest something even more exotic, that Atlas harbors hidden ices, strange compounds formed under alien starlight millions of years ago. If those exotic ices began reacting in ways we've never seen, they could weaken its structure from within, leading to the eerie split we're now witnessing. And then, of course, comes the most unsettling possibility: non-natural forces. The very phrase hangs in the air like static. Some recall how Oumuamua baffled scientists in 2017 with its unexplained acceleration, moving in ways no comet should. Could Atlas be following the same pattern? Could its breakup be the result of mechanisms we don't yet understand, or perhaps something deliberately engineered? The room grows quiet when these ideas surface. No one wants to say the words aloud, but the thought lingers. What if Atlas isn't just a comet? Whatever the cause, one thing is certain: Atlas is rewriting the textbooks. Its behavior doesn't align with any known cometary physics. It doesn't obey the rules. And that makes it not just a mystery, but a warning. Because if we don't know why it broke apart, then we don't know what might happen next. Could more fragments appear? Could hidden forces be shaping its path even now? And what risks might those fragments pose to our spacecraft, our missions, even our fragile grip on interplanetary safety? This isn't just about curiosity anymore. It's about survival. And the urgency to understand grows sharper with every passing hour. But to unravel the mystery, we must first ask a bigger question. What dangers could this strange breakup pose to the spacecraft and probes orbiting Mars right now? The split of three I/ATLAS isn't just an astronomical curiosity. It's a cosmic warning. Mars is no empty stage. Around the red planet orbit, satellites circle tirelessly, rovers crawl across its rusty surface, and instruments worth billions of dollars probe every crater and canyon. Now imagine a shard of interstellar rock hurled at nearly 60 kilometers per second, suddenly appearing in that theater of technology. Even the smallest fragment could punch through metal shields, fry delicate electronics, or obliterate a rover in an instant. The stakes are far higher than any scientific observation. NASA and ESA aren't taking chances. Teams are working around the clock, running non-stop simulations to map every possible trajectory of Atlas and its mysterious companion fragment. Computers churn through millions of calculations, predicting how each particle of dust, every tiny shard, might move, even accounting for the slightest gravitational nudge or outgassing force. Observation schedules for Mars orbiters and surface rovers are being rewritten in real time. Cameras are retargeted, spectrometers shifted, and engineers remain glued to their screens in tense vigil. It's a reminder of history. When Shoemaker Levy 9 shattered under Jupiter's gravitational grip, it rained fragments across the planet's atmosphere, leaving scars visible for months. No one had ever feared damage to human technology, but the lesson was clear. Fragmented objects can be dangerous. Now, for the first time, planetary scientists and engineers must apply that lesson to protecting our machines and eventually human missions. Mars may not yet host people, but it's crowded with probes, orbiters, and landers, a fragile network of exploration that Atlas's fragment could threaten. The concern isn't theoretical. Even a tiny misalignment in a fragment's path could intersect with a spacecraft moving hundreds of kilometers per hour. Teams model worst-case scenarios: debris clouds crossing orbital paths, tiny shards colliding with instruments, disruption of experiments designed to last years. Every potential collision is run through probability simulations, each adjustment creating a cascading set of new calculations. The atmosphere in mission control is tense. Every alert feels urgent, every observation potentially life-saving. For planetary defense, this is a wake-up call. It's no longer enough to study interstellar objects passively. Their behavior could pose real, measurable risks to human technology. NASA and ESA have learned that their data pipelines, communication systems, and rapid response protocols must be ready to handle anything, from a sudden asteroid fragment to a mysterious interstellar visitor defying all expectations. But as the agencies scramble to protect Mars missions, a broader question looms in the darkness. If fragments this small could threaten rovers and orbiters, what could happen if even larger pieces break free? Could Atlas, or another interstellar traveler, ever pose a danger to Earth, or is this the universe simply reminding us how little we truly understand about what drifts silently through the solar system? And that leads us naturally into the next chapter of the story, the bigger picture, the mysteries of interstellar objects, and why each new visitor like Atlas challenges not only science, but our very understanding of the cosmos itself. 3I/ATLAS isn't just a comet. It's a messenger from the depths of the galaxy, a wanderer carrying secrets from star systems far beyond our own. Its possible breakup near Mars has stunned scientists, but it also opens a window into the unknown. For decades, astronomers have studied interstellar visitors like Oumuamua in 2017, a bizarre object that zipped through the inner solar system with no visible signs of splitting or conventional cometary activity, leaving behind more questions than answers. Then came Borisov in 2019, a comet that behaved more normally yet carried strange chemical signatures rarely seen in solar system comets. Now, Atlas may be the first interstellar visitor to fragment in front of our eyes near a planet. Each of these arrivals tells a story, and each challenges assumptions. Oumuamua's unexplained acceleration suggested forces we barely understand. Borisov's chemistry hinted at unknown interstellar processes. And Atlas? It forces astronomers to ask, what does it mean when an object from another star system splits so close to a planet? Every fragment, every trace of gas, every shift in orbit becomes a critical clue. The cosmos is speaking, but its language is subtle, strange, and sometimes terrifyingly silent. The stakes are not just scientific, they are philosophical. Each visitor underscores how little we truly know about the galaxy we inhabit. Planets, stars, and comets are no longer isolated curiosities. They are part of a larger cosmic ecosystem that occasionally reaches out to touch our solar system in ways we cannot fully predict. Interstellar objects like Atlas force humanity to confront its own fragility, the thin veil separating order from chaos in space. Every observation is a race against time, a chance to decode patterns written over millions of years, carried across light years in frozen ice and rock. But the implications reach further still. If a fragment of Atlas can break off and drift near Mars, it raises questions about interstellar material interacting with planets elsewhere. Could other star systems experience similar events? Could these wanderers carry materials, chemical clues, or even phenomena that reshape our understanding of physics, chemistry, and planetary formation? Each new detection demands new models, new calculations, and new humility before the vastness of space. As the world watches, scientists around the globe are scrambling to gather every possible piece of data: imaging, spectroscopy, light curves, orbital analysis. They know that this single event could refine decades of planetary science and interstellar study, revealing connections between distant systems and our own backyard. Yet, for every answer, new questions emerge, leaving a trail of mystery that will keep astronomers, engineers, and curious minds on edge for years to come. The story of 3I/ATLAS is far from over. Its journey, its fragments, and its secrets are only beginning to unfold, and as we track it across the sky, one thing becomes painfully clear: the galaxy is far more alive, unpredictable, and astonishing than anyone ever imagined.